Welcome to myprojectbazaar.com. The title of the project is Automatic Detection of Exudates in Digital Color Fundus Images using Superpixel Multi-Feature Classification. Now we can see the abstract of the system. Medical systems based on state-of-the-art image processing and pattern recognition techniques are very common nowadays. These systems are of prime interest to provide basic healthcare facilities to patients and to support the doctors. Diabetic macular edema is one of the retinal abnormalities in which diabetic patients suffer from severe vision loss due to affected macula. It affects the central vision of the person and causes total blindness in severe cases. In this proposed system, the diabetic maculopathy is detected using the image processing techniques. First, the image is sent to pre-processing techniques in order to remove the noises. For that, we use bilateral filtering technique. After the pre-processing, the segmentation of the macular region is done by using the odd-surf segmentation method. After that, the features such as thickness, size, and area and centroid, which are called as local features, are extracted from the image. By using these features, the classification step is performed. Here we use decision tree classifier for classification. Finally, the performance of the system is evaluated by using the performance measures such as accuracy, precision, and recall values of the image. The main objective of this process is to perfectly extract the multi-channel features and the local features, to detect and classify the macular candidates in the dataset images, and to improve the performance of the system based on accuracy and sensitivity values as compared with the conventional existing system. Now we can see the flow diagram of the system. In this proposed system, the diabetic maculopathy is detected using the image processing techniques. First, the image which is to be pre-processed is taken. The pre-processing like image resize, color conversion, channel separation, and bilateral filtering is done. Then the image is resized. The RGB color image is converted to grayscale image in the color conversion part. Then the RGB converted image is separated into a red channel, green channel, and blue channel image in channel separation part. Then, to remove the noises, bilateral filtering is used. A bilateral filter is a nonlinear, edge-preserving, and noise-reducing smoothing filter for images. It replaces the intensity of each pixel with a weight average of the intensity values from the nearby pixel. This weight can be based on a Gaussian distribution. Crucially, the weights depend not only on Euclidean distance of pixels but also on the radiometric differences. After pre-processing, the segmentation of the macular region is done by using the odd-surf segmentation method, and also the blood vessel thickness in the macular region is calculated. After that, the features such as thickness, size, area, and centroid, which are called as the local features, are extracted from the image. By using these features, the classification step is performed. For that, we use decision tree classifier. Decision tree builds classification or regression model in the form of a tree structure. It breaks down a data set into smaller and smaller subset, while at the same time an associated decision tree is incrementally developed. The final result is a tree with decision nodes and leaf nodes. Finally, the performance evaluation of the proposed system is done by using the performance measures such as accuracy, sensitivity, precision, and recall values of the image. In this proposed system, the diabetic maculopathy is detected using the image processing technique. Now we can see how to execute the code. This process is done by using MATLAB R 2013A version. Now you can open the MATLAB R 2013A version. When you open, you will find this page. Then you can copy the location where you have placed your source code and paste it here. You will find dataset and other coding part here. Now you can give right click on main guy 1 and give run option. Thus the main guy 1 part opens here. Here we have taken image acquisition, that is the input image we are going to fetch, then do pre-processing techniques like image resize, grayscale conversion, and then RGB image is individually separated into red channel image, blue channel image and green channel image. First, the image which is to be pre-processed is taken. You can click image acquisition button. It will get a set of images. This is the data set from which you can select your desired one. Give open. Thus the input image appears here. Then image resize, that is a pre-processing technique is performed. When you click image resize, you will get image resized here. Then grayscale conversion, grayscale image appears here. Then when you click on red channel separation, you will get red channel image alone. Then blue channel image alone you will get here. Then green channel image you will get here. When you give next, the next main guy 2 will open here. Here we can see filtering, macula segmentation, vessels extraction, vessels overlapping, vessels information, feature extraction, classification and performance. In filtering we do bilateral filtering to remove the noises. When you give filtering option, the filtered image appears over here. Then macula segmentation. Here segmentation is performed by using the outsource segmentation model. When you press macula segmentation button, you will get macula image. It will represent where the macula is present in the retinal. Then vessel extraction. This image shows the vessels that pass through the retina. Then vessels overlapping. Vessels information. Vessels information, we get information like vessels thickness and also the area. Feature extraction. These are the features as we have saw before. These are the thickness, area, center. All those values are the features which are called the local features are present over here. Then classification. Here we use decision tree classifier. The classification shows that this data set has the severe stage of macula. Then performance. Here are the performance values accordingly like accuracy, sensitivity, scalability, like that. This is the performance graph. Here the performance value is taken against the accuracy, sensitivity, specificity, precision, recall, F-measure and overlap. Thus, from the performance evaluation graph, we come to conclusion that the proposed system is far better than that of the existing system. Thank you for watching.